Good morning to Madam Iza. My name is Esther and today I've been carrying out two experiments, which is the electrolysis of water and the electrolysis of copper 2 sulfate. I will start off with the electrolysis of water, and here are my apparatus and materials. I have a cardboard with two holes and my NaCl salt, beaker, 250 ml of warm water, 2 pencils, 1 9-volt battery, and 2 crocodile clips. So first of all, I will pour 250 ml of warm water into the beaker. Next, I will set up the apparatus by placing the 2 pencils into the hole of my cardboard. And next, I will place this pencil on top of the beaker, like this. Next, I will connect the 9-volt battery with the crocodile clip, with the alligator clip, to connect to each pencil tip. So the anode, which is the positive electrode, where the oxidation will occur, and you will know that the oxygen ions will be attracted as the oxygen ion is negatively charged. So I will connect it with one of the pencil tip. Next, I will connect one alligator clip into the negative electrode, which is the cathode, where the reduction process will occur, and hydrogen ions will be attracted as hydrogen ion is positively charged. So we'll observe it for 5 minutes. After observing for 5 minutes, we notice that there are air bubbles appears in both pencil tip, and the air bubbles at the cathode, where the hydrogen ions is present, is more than the anode side, which is the oxygen ion. This is because water is formed with H2O, which means that the hydrogen are more than the oxygen. So we will notice that the air bubbles at the cathode is more than the air bubbles at the anode. The gas present at the cathode is the hydrogen gas, and the gas produced at the anode is the oxygen gas. So now I'll add some NaCl salt into this warm water and observe for 5 minutes more. After stirring and make sure that the salt are fully dissolved, I will now place back the electrode and observe for another 5 minutes. After adding salt and observe for 5 more minutes, we notice that air bubbles will appear in both electrodes, and the hydrogen gas appear to be more than the oxygen gas at the anode. So this is our hydrogen gas and this is our oxygen gas. So this is cathode and the other side here is anode. Now I will proceed with the second experiment, which is the electrolysis of copper to sulfate. Here are my apparatus and materials. I have my copper to sulfate, 3 grams of copper to sulfate, beaker, 250 ml of warm water, 2 alligator clip, 9 volt of battery, 2 pencils, and 1 cardboard with 2 holes. I will first pour 250 ml of warm water into the beaker. Next, I will pour the 3 grams of copper to sulfate into the warm water. Next, I will stir the copper to sulfate to make sure it is fully dissolved. Now done with the stirring, all our copper to sulfate is fully dissolved, and I will proceed the next step by setting up my apparatus. And I will connect with the crocodile clip. Then I will place my electrode into the copper to sulfate and observe for 5 minutes. This is our positive electrode. So this will attract the oxygen ions, and whereas our cathode will attract the copper 2 plus ion. So the reduction will take place in the cathode, whereas the oxidation will take place in the anode. Now let's observe for 5 minutes. After 5 minutes, we notice that our air bubbles is appeared at our anode side. So here there is air bubbles, and whereas the cathode there are brown precipitate. So this brown precipitate is our copper metal, whereas the gas produced at the anode is our oxygen gas. So for our observation, there will be 3 observations made. First is the air bubbles will appear at the anode, which is our oxygen gas. This is our anode, and the brown precipitate will be formed at the cathode, which is the copper metal, and the third one is the copper 2 sulfate solution change color from dark to lighter blue. So that's all for our experiment today. Thank you very much for your time.